Nuclear power plants are amazing feats of engineering. They harness the power of atoms to generate electricity for our homes and cities. These plants are like giant powerhouses, capable of producing enough electricity to power a city of 2 million people. That's a lot of homes, schools and businesses, all powered by the energy released from tiny atoms. Nuclear power is a major source of electricity around the world. It's the second largest source of low-carbon energy, which is very important for our planet. About 10% of the world's electricity comes from nuclear power plants. This means that millions of people rely on the safe and efficient operation of these plants every single day. Nuclear power plants may seem complicated, but the basic principles are fascinating. By understanding how these plants work, we can appreciate the science and technology behind this important energy source. Let's take a closer look at the different parts of a nuclear power plant and how they all work together. Nuclear power plants consist of several key buildings. Each has a special role in generating electricity. The containment building is crucial. It houses the reactor, the plant's heart. Made of thick reinforced concrete, it withstands extreme conditions. It acts as a safety barrier. The turbine generator building generates electricity. It houses a giant turbine connected to a generator. Finally, the control room is the plant's brain. Operators monitor and adjust the reactor's power output. Nuclear power plants use a special kind of fuel called uranium. Uranium is a heavy metal found in rocks and soil all over the world. It contains a lot of energy that can be released through a process called nuclear fission. To make nuclear fuel, uranium is processed into tiny pellets about the size of your fingertip. These pellets are then sealed inside long metal tubes called fuel rods. The fuel rods are bundled together to form fuel assemblies, which are then loaded into the reactor core. The reactor core is where the magic happens. When the uranium atoms inside the fuel rods are hit by neutrons, they split apart, releasing a tremendous amount of energy in the form of heat. This process is called nuclear fission. It's like splitting wood, but on an atomic level. Section 4, controlling the reaction. Nuclear fission is a powerful process and it's important to control it very carefully. That's where control rods come in. Control rods are made of materials that absorb neutrons. By inserting or withdrawing these rods into the reactor core, operators can control the rate of the nuclear fission reactions. When the control rods are fully inserted, they absorb most of the neutrons, slowing down the fission process. When the control rods are withdrawn, more neutrons are free to collide with uranium atoms, speeding up the reaction and producing more heat. The operators in the control room constantly monitor the reactor's power output and adjust the control rods as needed. This ensures that the fission reactions happen at a safe and controlled rate. It's like a dimmer switch for the reactor. Section 5. Making electricity. The heat from nuclear fission in the reactor core creates steam. This steam drives turbines to generate electricity. The reactor vessel contains fuel assemblies and heavy water. Heavy water acts as a coolant and moderator. It carries heat away and slows down neutrons. Heated heavy water goes to steam generators. There it heats ordinary water to create steam. The steam spins turbines, powering generators. These generators produce electricity for our homes. And that's how nuclear power plants generate electricity.